Good morning, everybody. My name is Farnaz Pirasteh, and today I'm here to talk about variable selection in near-infrared spectroscopy using Lasso Algorithm. And my advisor is Professor Liu, and in Intelligent Systems Lab in Pukyong National University. So new inventions in any kind of science has resulted in our work to high-dimensional data sets. It means that the number of variables which is in our hand these days are too many, so we need to overcome this problem in such a way. For example, in imaging, you can see we have thousands of number of images, thousands of number of pixels, but only limited number of images. Or in gene experiments, or in social networks, or in finance, these are the problems which we have, which we control thousands of variables. So the good case we can overcome this problem is variable selection methods. So variable selection is to improve the prediction performance of the predictors, to provide faster and more cost-effective predictors, and to provide a better understanding of the underlying process that generated the data. As you see, variable selection is really more important in high-dimensional data, which we consider more and more number of data. So in this case, we have statistical accuracy, model interpretability, and computational complexity. We need to consider about these items. But the problem here is that in classical model, we require a number of variables lower than number of observations. So here, in high-dimensional data, we this problem is with OLS estimation, ordinary least square estimation. So we need to actually face this problem in such a way. So in the 1996, Tip Shirani presented Lasso algorithm for this problem. Before that, we had subset selection, ridge regression, which both of them have some withdrawals. So after that, in 1996, with Lasso algorithm, we could overcome this problem. And this is to minimize this function. And for example, considering this function, if we consider t to the half of the number of variables, so it means that the best subset of variables can be considered as half of them. So, and you can see here in this figure also. And after that, another efficient algorithm for this problem is presented 10 years after that, in 2004, by Efron et al. Lars algorithm, least angle regression. It works like this. Initialize each entry of coefficients equal to 0, find the predictor most correlated with y, and increase the predicted coefficients, the most correlated with y, and then calculate the residuals. And so find the predictor with same correlation, and go on until to find the threshold of correlation. So in this study, we are going to consider a case study and consider data mining processes on the problem. So data mining process includes business understanding, data preparation, modeling, and evaluation. The case study here is concerned with soil carbonate. As you know, carbonate is the key component of soil, and the carbonate affects the chemical and physical properties of the soil, and so fertility and productivity properties. So the samples are from Dr. Victor Brockman from Austria, and they are from Eastern Austria in a Kyrgyz-dominated high forest management system, Northern Limestone Alps. So the samples are gathered like this. So 10% of our samples could be considered in this study. And they are determined by a pH CaCO2 value greater than 6. And the process is like this. So samples were sieved to 2 millimeters. Subsample was ground to powder, and then to powder for FTIR, Fourier transform, infrared spectroscopy, and XRD analysis. So the data set is in our hand is wave numbers, FTIR, and XRD. So as you see, we have about 7,400 variables, and here for XRD we have around 3,800 variables, but only 41 number of observations. So you can see the huge difference between number of variables and number of observations. So actually totally we have around 11,000 variables with only 41 number of observations. Okay, so to overcome this problem, we used Lasso Algorithm, but in order to compare with another innovative feature selection algorithm, we used PGA, parallel, PGA and also some classical feature selection methods, such as forward selection and stage-wise selection. So you can see in stage-wise selection, the R-square is 0.7, and for stage-wise selection, the R-square is 0.78. And here, if we consider the errors, RMS EP, MSE and percentage of error, they are quite high for the prediction error. So then, by running Lasso, we gain 84 variables and also Lars. In 35 steps, we gain 78 variables, and also by PGA, parallel genetic algorithm, we gain 66 variables. And to compare the efficiency of each algorithm, we use tenfold cross-validation. And so finally, you can see here that for Lars, we have R-square 0.97, for Lasso R-square 0.96, and for PGA 0.86. So if you see in this table also, for RMS EP, for Lars we have the best result. So actually this is the algorithm which is designed for the case which the number of variables is much more than number of observations. So in this case study also, you can see the efficiency of this algorithm to predict the carbonate content more efficient. Actually, the most efficient one. And thank you for